Welcome to The Explainer. Today, we're going to crack open one of the cleverest forms of cyber attack out there, blind SQL injection. You can think of it like a digital heist, where the thief has to rob a vault they can't even see.
So let's just start with a puzzle. How would you steal a secret from a database when the application gives you absolutely zero feedback? I mean, no data, no error messages, nothing. This is the exact challenge an attacker is up against.
You see, in a normal SQL injection, the attacker gets something back. They poke the database and it spits out a list of usernames or maybe a helpful error message. But with blind SQL injection, you get nothing. The application gives nothing away. The attacker is flying completely blind, which forces them to get really, really creative.
And you know where this often starts? With something that looks totally innocent, like a tracking cookie. A website might use a tracking ID to see if you're a returning visitor, right? And that check involves a quick database query. For a hacker, well, that's the only crack in the door they need.
Okay, so let's dive into this first technique. And honestly, it's just brilliant. It turns this really complex attack into a simple game of yes or no. Pretty much just like 20 questions.
The attacker's first clue is usually just a tiny, subtle change in how the website behaves. For instance, maybe a welcome back message pops up, but only if their injected query turns out to be true. That little message, that is the yes signal they've been searching for.
And look at how this works. It's so clever. By injecting a statement that is always true, like and 1 equals 1, they get that welcome back message. Then they inject something that's always false, like and 1 equals 2, and poof, the message is gone. Just like that. They've built a system. They can now ask the database any yes or no question they want.
And this shows you exactly how they can piece together something like a password. They don't ask, what is the password? Because that won't work. Instead, they ask these tiny little questions. Is the first character greater than M? Yes, they get the welcome back message. Okay, is it greater than T? Silence, so no. Through this process of elimination, they deduce the entire password, one character at a time.
But what if the application is really well designed and it shows no change at all? That little welcome back trick is completely useless. So, what happens when attackers hit this wall? Well, this is where they have to escalate their methods.
And this right here is basically the attacker's playbook. If one method is blocked, they just move on to the next one. They can try to force an error, or maybe introduce a time delay, or in a last-ditch effort, even make the database phone a friend.
So the first escalation is to try and break the database on purpose. But, and this is the key, only if a specific condition is true. If they can make the application crash or show an error page, that crash becomes their new yes signal. They'll use a sneaky piece of code like this. It's designed to fail by asking the database to do something impossible, like divide by 0, which always causes an error. But it only does that if the attacker's hidden question, in this case 1 equals 1, is true. If the page breaks, they know the answer is yes.
Okay, but what if the application is so robust that it catches all those errors and just handles them silently? Now what? Well, a really clever attacker can then turn to manipulating time itself.
Using a command just like this one, they can tell the database to literally just pause, do nothing, for let's say 10 seconds. But again, it only happens if that secret condition they are testing for is true.
So the crucial point is, the attacker starts a stopwatch. If the page takes an extra 10 seconds to load, they know the answer to their question is yes. The silence from the application is broken by the delay. They're actually using time as their feedback channel.
And this brings us to the most powerful technique, the one that works even when the application is a complete black box and all the other methods have failed. It's called out-of-band application security testing, or OAST. So, what happens when nothing works? I mean, no response changes, no errors, no time delays. Maybe the query is running on a separate thread, so you can't even see its effect. The attacker is truly blind now. Or are they?
The solution is OAST. It's kind of like forcing the database to phone a friend. And the crucial part is, that friend is a server controlled by the attacker. They aren't waiting for a signal anymore. They are forcing the database to send one out.
An attacker can inject a command like this one, which forces the database to make a network request,
like a simple DNS lookup, to a web address the attacker owns. The second their server gets that ping, they know they have control.
And here is the absolute masterstroke. They don't just use this connection to get a simple yes or no. They use it to exfiltrate the data directly. They basically tell the database, hey, take the administrator's password and put it inside the domain name you're about to look up.
The attacker's server then gets a DNS request that looks something like this. And there it is, right in the subdomain, the administrator's password, S-Secure. The unseen heist is now complete, and they did it without ever seeing a single direct response from the application. So, after seeing these incredibly clever and escalating attacks, the big question is, how do we defend against them? Well, the solution, thankfully, is a lot simpler than the attack itself.
The single most effective defense is a coding practice called parameterized queries. It's a simple but really powerful concept that draws a hard line between code and data. Any user input is always treated as just plain data, which means it can never be mistaken for a command for the database to run.
And that leaves us with the final thought. Blind SQL injection reveals this whole hidden world of communication happening inside our applications, which kind of makes you wonder, what other invisible conversations and vulnerabilities are lurking in the code we use every single day?